This is Algebra 1, Lesson 1.3. We're doing order of operations. A couple of goals. We're using the order of operations to evaluate algebraic expressions. And then we're actually not going to look at this part, how calculators do it. Some calculators work order of operations, and some of them do it exactly how you input it. You'll be able to tell that right away when you use your own calculator. We don't need to spend any time on that. Beginning on page 16, the first thing we have is a definition of what the order of operations is. It's rules established to evaluate an expression involving more than one operation. If you don't have this exactly word for word, everybody, you don't have to change your definition. Just make sure it's paraphrased. Make sure you're not missing anything off of this. If you have this written just in slightly different wording, it's okay. More than one operation. It's just the order. It's the rules if there's more than one operation. Example number 1 is evaluating without grouping symbols. So what we have is 4x squared plus 3 when x is equal to 3. So the first thing you're going to do is substitute in this value 3 in place of x. So 4 times 3 squared plus 3. And when you substitute something in, it actually, again, acts as if it's inside of a set of parentheses. That makes a difference when you're talking about negative numbers. So the first step, again, is to substitute in 3. The second step is to evaluate the power. So what that means is to take 3 and square it. 3 squared gives you 9. The next step is to do the multiplication. 4 times 9 and get 36. And then the last step is to evaluate the sum, do the addition part. 36 plus 3 is in fact 39. Okay, so sub it in, do the exponents, do the multiplication, do the addition. And again, that's please excuse my dear Aunt Sally. Most of y'all are familiar with that. Parentheses, exponents, multiplication, division, addition, and subtraction. Here's another example that is not on your sheet. Everybody turn over to the back and do this one real quick. Should only take you, 20 seconds or so. Copy the problem, work to it, and we'll go over it in just a second. Okay, let's take a look at it. 4x squared minus 8. First thing you're going to do is in place of x, you're going to plug in 3. So 4 times 3 squared minus 8. Before you do multiplication, you have to do the exponent. So you have to square 3. 3 squared is 9, not 3 times 2. It's 3 times 3. Remember that. So now we have is 4 times 9 minus 8. 4 times 9 is 36. And then do 36 minus 8, and you get 28 for that one. 28. Right next to that one, here's another one. Do this one. Try again. Take about 30 seconds. X is still equal to 3. Same direction. Okay, the first thing we're going to do is sub in 3 in place of that x. So now we have 27 divided by 3 squared plus 3. Again, order of operations says we have to evaluate exponents first. 3 squared is 9. So we have 27 divided by 9 plus 3. Before you do addition, you divide 27 by 9 to get 3. And then finally, 3 plus 3, the addition part at the end is 6. Example number 2 is using the left to right rule. Um, when you write out, please excuse my dear Aunt Sally, you'll always see math teachers write it this way. Notice I don't have the M and the D stacked on top of each other, nor do I have the A and the S stacked on top of each other. They are on the same line with each other, which means they're given the same priority. What that means is you do not skip over subtraction to do addition. You do not skip over division to do multiplication. That's what the left to right rule means. Like if we look at A, it says 28 minus 7 minus 4 is equal to, and then it shows you what the steps. That's minus for both of them. So you know you would do 28 minus 7, get 21, and then subtract 21 minus 4 and get 17. That's just using the left to right rule. More often than not, when it shows up where people make mistakes is when there's two different operations together. This one right here says 15 plus 9 divided by 3 minus 4. Now you have plus and minus, but there is a division in the middle. That's the one you have to do first. So you have to skip the addition and do 9 divided by 3 and get 15 now plus 3 minus 4. Then you do 15 plus 3 and get 18 minus 4. And then finally 18 minus 4 to give you 14. Very simple. Again, none of this should be ridiculously hard to you. You look off to the right, it says operations that have the same priority. I'm sorry, the left, my other right. Such as multiplication and division or addition and subtraction are performed using the left to right rule, shown in example 2. Again, everybody on the back, copy this problem down. 32 minus 16 plus 2. Here's a good example of what I was talking about. Take about 30 seconds. Okay, 32 minus 16 plus 2. You do not skip over that subtraction of 32 minus 16 to do the 16 plus 2. You do 32 minus 16 and you get 16, and then 16 plus 2 to get 18. Do this one right next to it. Again, do not skip over 48 divided by 3 to do 3 times 2. 48 divided by 3 is 16, and 16 times 2 is 32. And then do this last one next to it. And then this one's a little bit easier for most people because you know you have to skip over addition to do division. That's a different priority step. 6 divided by 3 is 2. 12 plus 2 minus 2. Then 12 plus 2 is 14 minus 2. And 14 minus 2 is 12. Okay. Going back to B though, 48 divided by 3 times 2. Remember, multiplication and division go together. You do not skip over division to do multiplication. Same thing with addition and subtraction. They go together as well. You don't skip over addition, subtraction to do addition. You do them from left to right. Here is officially your order of operations. First, do operations that occur within grouping symbols. Please, that's the please part of please excuse my dear Aunt Sally. The second one is evaluate powers. That's the excuse part, exponents, parentheses, than exponents. Remember, there are more grouping symbols than just parentheses. So don't think it's not brackets and braces and stuff like that, and we'll look at those as we go. Number 3 says do multiplications and divisions from left to right. So do those from left to right. Again, don't skip division to do multiplication. And then finally, number 4, do additions and subtractions from left to right. Multiplication and division, addition and subtraction. Again, notice they're written on the same line, not after each other. M and D and A and S. Here's example number 3, using a fraction bar. What a fraction bar is it is a grouping symbol. That's all it is. It's a grouping symbol when you're talking about the order that it falls in. So it acts like the bottom is in a set of parentheses. It acts like that's in a set of parentheses and this is in a set of parentheses. So what that means is you have to evaluate everything at the top and everything at the bottom before you try to move anything from top to bottom. So first off, we have 5 times 3 on the top over 13 plus 6 squared minus 4. According to our order of operations, tells you to do what's inside the grouping symbols first, then do your exponents, and that's why we do 6 squared to get 36. The next thing tells us to do multiplication and division, which means on the top we'll multiply 5 times 3 to get 15. So that's the please part. This is the excuse part. This is the multiplication and division part. Then the last step, we'll do 13 plus 36 and get 39. And then 49, excuse me, and then 49 minus 4, we'll do that addition and subtraction from left to right and get 49 minus 4 is 45. Now, you have something that says 15 over 45. Never leave a fraction in an unreduced form. You don't even have to ask that question from now on. From now until you're finished with math classes, never leave something with something that you could reduce like this. The number 15 goes into this, it goes into itself once, and it goes into 45 3 times. So the simplified version is 1/3. Again, one more problem for the back, everybody. Simplify this expression, 24 times 3 over 5 plus 3 squared minus 2. Take about a minute for this one. Okay, first thing we do is our parentheses. Remember, fraction bar acts like it looks like this. So do everything at the top, then we'll do everything at the bottom. You don't need to draw those in. I'm just showing you that's what the fraction bar does. Okay. The next step we have is our exponents part. We have 3 squared right here, so we can take care of that. So evaluate what's on the bottom. 5 plus 3 squared is going to be 9 minus 2, so we still have 24 times 3 at the top. The next part of our order of operations is multiplication and division. So we have multiplication in a problem. 24 times 3 is going to be 72 on top. So 72 times 5 plus 9 minus 2. And then the last part of our order of operations is our addition and subtraction. I'm sure I can't change colors, but our addition and subtraction, and you're going to do 72 is going to be on top still. 5 plus 9 is 14, and 14 minus 2 is 12. Okay, so now we want to check and see if there's a number that goes into both of those. We know for sure it's even, so 2 is going to go into it, but let's see if 12 goes into it. 12 times... Okay, 12 doesn't, but 6 does. So what we want to do is 6 goes into 72. It goes into 7 one time, and there's 2 left over. Sorry, there's 1 left over. 6 goes into 12 twice, and it goes into 12 2 times. So again, 12 divided by 2 is going to be 6. So the number 12, excuse me, I'm having a little trouble with my arithmetic today, but it does 12 times 6 is in fact 72. 12 times 6. So 6 is your simplified answer. But again, what we're looking at today is following the steps, following the order to get to the number 6. And then we have 4 checkpoint problems. We'll go quickly through these. 29 minus 4b when b is 6. The first thing we're going to do is sub in 6 right there. 29 minus 4 times 6. Order of operations tells us to do multiplication first. Negative 4 times 6 is negative 24. Negatives act just like minuses, and minuses act just like negatives. There's no difference. So 29 minus 24 is going to be the number 5. Number 2 says 18 minus 42 over c when c is 7. So in place of c, we're going to plug in or sub in 7. 18 minus 42 over 7. 42 over 7 can be reduced to the number 6 because 6 times 7 is 42. So we have 18 minus 6, and then 18 minus 6 we know is 12. Again, order of operations. Please excuse my dear Aunt Sally. Don't skip division to do multiplication. Don't skip subtraction to do addition. 2 times 3 squared plus 4 over 7. Exponents come before addition and subtraction or multiplication and division. So we have now is 2 times 3 squared. 3 squared is not 6. It's 3 times 3, which is 9, plus 4 over 7. 2 times 9 comes next because you do multiplication before addition and subtraction. 2 times 9 is the number 18 plus 4 over 7. So now we have fractions we have to add. Remember, everything can be written as a fraction by putting it over 1. The bottom numbers have to be the same, though. We have to have common denominators. In this case, the smallest number they both go into is 7. What that means, though, is we have to multiply this number by 7, which means we have to multiply 18 by 7 and get a great big number. 8 times 7 is 56. We'll carry our 5. 7 times 1 plus 5 is 126, plus 4 over 7. So the bottom number is now the same. We'll leave it the same, 7, and we'll add straight across. 126 plus 4 is going to be 130. Now 130 divided by 7, if you make it into a mixed number, all it says is 130 divided by 7. 7 goes into 130 18 times, and there are 4 over 7 remaining. So this is a mixed number version right here. 18 and 4/7. 22 minus 4 to the third power divided by 8. So you're going to do the innermost parentheses or the innermost grouping symbol first. 4 to the third power doesn't mean 4 times 3. It's 4 times 4, which is 16, times 4, which is going to be 64. 64 divided by 8 is next. 22 is subtracting that, and it's still multiplying by 3 after the fact. So again, this is still the innermost set of parentheses. So 64 divided by 8 is 8. So 22 minus 8, then it's multiplying by 3. Again, you have to do what's inside parentheses first. 22 minus 8, 22 minus 8 is going to be 14. Then 14 is multiplying by 3, and we're getting 42 from there.